Point and slope. All right. Do you have both of those on this one? What's your point? What's your slope? How do you figure this? I don't tell it to you. But I tell you enough information for you to figure it out. Why would I tell you that your line's parallel to that line? The same slope. So how do I find that slope? I get isolate y. I get y by itself. All right, so how am I going to get y by itself? What have I got to get rid of over here? The 3x. All right, how do I get rid of a 3x? All right, so if I subtract 3x from both sides, the 3x are going to go out over there, aren't they? Now that's not going to leave me 4y, it's going to leave me a what? Negative 4y, so you got to be careful with your signs. All right, now I don't want negative 4y, I want just y. So how do I get rid of that negative 4? Divide. All right, so a negative 4 divided negative 4 is 1. What's 1 times y? Y. That's that identity multiplication property. All right. And so then I've got a positive divided by negative, so I've got a negative 11/4. What's a negative divided by negative? Positive, and I've got 3x over 4. So when you get y by itself, where's your slope sitting? Right in front of x. Just make sure you take everything with it. So what's the slope of this line? That slope is what? 3/4. So what's my slope? 3/4. Why? Because they're what? They're parallel, so the slopes are the same. So what would I have over here? Y minus, what's the y part of my point? 4. What do we say our slope was? 3/4. And then I have x minus, what's my x coordinate? 0. Everybody okay? But now, instead of saying parallel, what if I had said that it's perpendicular? That's right. If I said it goes through this point, it's perpendicular to that, I'd have my point. My scratch work wouldn't be any different. But like Tucker said, if the slope of this line is 3/4, what's my slope? Negative what? 4/3. Because with perpendicular lines, first of all, you have to change the sign. So if this one's positive, yours is negative. This one's negative, yours is positive. And then you have to do what to it? Flip it. You have to take the reciprocal of it. Okay.
On finding the slope, could I do negative a?
Sure.
No,
No, that's fine.
wasn't Judy wanted the full scratch?
Just make sure you don't show me a little bit of scratch work, just so in case you make a careless error. Okay? So there are lots of ways I can ask you to write a linear equation. But anytime I tell you to write a linear equation, what 2 things do you need? A point and a slope. Now, the only time that will fail you is if I say something like this. There's only one time that's going to fail you. What if I said that your line went through these points? 3, 4, and 3, 7. Well, I still need a point and a what? Slope. And it doesn't matter which point I grab, right? But remind me how I find slope. All right, y2 minus y1 over what? x2 minus x1. So I'm going to have 7 minus 4 over what? 3 minus 3. What's the problem?
0.
I'm 0 on the bottom, so what's my slope? Undefined. And see, I can't put the word undefined right there. It's got to be a number. So the only time this formula is going to fail you, what kind of line would this be? What kind of line would go through those 2 points? All right, let's look at it. 3, 4. Right? And then 3 what? 7. What kind of line goes through those points? Vertical. Well, then you should almost know the answer automatically. What's the form of every vertical line? X equals a what? Number. So what am I going to put for my answer? X equals, apparently what is X equal here? 3. How'd you get that, Tucker?
Because it runs, that's the.
That's what it runs through. Every point on that line, the first quarter is gonna have to be what? 3. So the only time that that's gonna fail you when you're writing a linear equation is when it's vertical. It won't even fail you when it's horizontal. Because if it's horizontal, what's the slope? If I ask you that on your test Friday, what's the slope of every horizontal line? What's the slope of every horizontal line? How steep is that? 0. It's 0 steepness. Well, I can plug 0 in there, 0 is a number. But when it's a vertical line, how steep is it? Is that very steep? Yeah, that's so freaking steep, there's not a number to tell you how steep it is. It is an undefined steepness. So the only time that formula right there, that form of that equation is going to fail you is when the line is vertical. Because you can't put a word right there. But if it's vertical, you know the linear equation is x equals some what? Number. Look at your point. X's. Every point on that line is going to have x be 3, because you have to go over 3 and then go up a certain amount, or go over 3 and go what? Down a certain amount.
So what we put there, that's the scenario.
Yeah, in other words, if I ask you that, I would expect you to x is 3.
We wouldn't put it in the scenario.
You can't put it in the formula. Okay. Now, you also have some word problems, so go back and look over those word problems that deal with linear. What 2 things are you going to need every time? Point and a what? Slope. Now, sometimes they give you the point. Sometimes, though, when you go back and look at your word problems, you had to create the points. So if you're missing the points, then you're going to have to figure them out. You know, one time it was comparing like the age to the price of the equipment. One time it was comparing, I don't remember all the different things you compared. You know what I'm saying? But you're always comparing, you know, the year to the number of people. I mean, but you go back and look at those word problems that deal with that on those linear equations. Okay? So make sure you do go back and look over that. So that's one thing on your test. John?
You said the horizontal graph is always going to be with.
Horizontal, if it's horizontal line, what's the slope always going to be? 0. Vertical has undefined. Okay? All right. Now, something else on there were functions. Now, you had a pop test last time. Man, I meant to bring that down. I'll go back up and get it toward the end of class. Excuse me, so that you can look at that. But, you know, those pop tests you had, you give them to substitute in, like F at -1, F at 3. Those compositions. Is everybody okay on that pop test thing?
Those are too far.
Those are big.
The video.
Oh, the
video.
strong.
Right. Okay. So is everybody clear about that? All right. Now the other thing to do with functions. Now also make sure you go back and look over those piecewise functions. I mean the ones on the pop test weren't piecewise. So sometimes you have like an x squared if x is bigger than say 4. It may be 2x minus 3 if x is less than or equal to 4. So if I tell you to do f at -1, should you substitute in the top, the bottom, or both?
No.
Why the bottom? Because that's your x. So is your x less than 4 or is your x bigger than 4? What's -1? It's less than 4, so it should just go in that bottom piece. Now, what if I said find f at 10? Everybody see why it's going to go on the top? Because that's your x value, and 10 isn't smaller than 4. 10's what? Bigger than 4. So what are you going to do with that 10? You're going to square it. Is everybody with me? What if I plugged in exactly 4? Where does it go? Why? Because it says use the bottom if it's less than 4 or if it's what? Equal to 4. So make sure that you go back and look over substituting things into functions. All right, we also talked about domains of functions. So if I gave you a problem like y equals 3x squared minus 4x plus 1/17, or if I said y equals the square root of 2x plus 10, or if I said y equals 3x over x minus 5.
Up here.
Yeah.
Why did you put the 4 into the bottom equation? That one you just erased?
Because it said, if I remember right,
It was x is
it was
Less
x
than or-
squared if x is less than or equal to 4, and it was, what was the top part?
2x minus 3.
2x minus 3 if x is what? Bigger than 4, and I said do f at 4.
No, it's
I think,
the x's are swapped.
yeah.
Oh, these are swapped?
Yes, ma'am.
Okay.
I was gonna ask the same thing.
All right, so what was this one?
That one is greater than 4.
This one's greater than 4. What's this one?
I think that one.
Equal to.
Less than or
Equal to.
equal to 4.
Yeah, and you put it in x.
I put it in here, didn't I?
No, you put it in the top.
Oh, okay, no, it should go where the one is equal, so if I
Yeah.
switched it, then you need to fix it on your notes.
Okay.
All right, so wherever it is equal, so if it's equal right here, it goes right there. Okay. If it's greater than 4, it's gonna go up there. So if that's wrong, I put it on the board wrong, because I raised it, so I put it on the board wrong, fix it.
Okay.
Okay, I don't want you to take it home wrong with your notes. Okay? Now, if I ask you for domain and range, we went over this. What are your 2 trouble spots on domain? What are your 2, how are you gonna find the domain on this one? What does domain mean? Your x's. What x's are legitimate right here for you to plug in? If you plug in a 3, and I plug in a negative 1 over 17, what can I not plug in? So what's your domain? All real numbers but what? 5. Now, how did you figure that out in your head? How did you know it was all real numbers but 5? So what were you worried about having a 0? The denominator can't be 0. So if you look in your notes, what does it tell you to do? Like flip back in your notes right now and find where you were doing it, because it was on a video, I think, so you should have some good notes on it. Yeah, if you had trouble spots, it tells you that you had 2 trouble spots. So what's one of them?
When you have a fraction with a variable.
When you have a fraction with a variable. So what does it tell you to do in your notes when you have a fraction with a variable? Set the denominator equal to what? 0. So if I set x minus 5 equal to 0 and add 5 to both sides, I get x is what? 5. And then your notes say that your domain is all real numbers what? But that. Now sometimes you can see by glancing, but if I put it this way on your test, you might not. Now you got x squared minus 36 is what? 0. Well, you learned before the last test how to factor. So we can't forget what we're supposed to know. So that's the difference of perfect squares. What does that factor into? X what? Minus 6 times what? X plus 6. So what are the 2 answers to this? 6 and negative 6, because if x minus 6, if this one's 0, that means x has to be 6. If that one's 0, then you solve that, that means x has to be a what? Negative 6. So is this domain 6 and negative 6? What's the domain for this? All real numbers but what? 6 and negative 6. All right, look at number 2. What do you do? What do your notes say you do when you have an even powered root? Okay, what is it? The radicand. All right, so you got to go study. You got to go back and look over all those notes. So the radicand is the stuff under the root. So your notes tell you to take that radicand and do what with it? Set it not equal to 0 like we did down here, but what? Greater than or equal to 0. So, Darren?
Is it always going to be greater than?
Yes.
Okay, just making sure.
Yeah, always. This one's always greater than or equal to 0. This one's always what? Equal to 0. And the reason it's got to be greater than is this. What's under the root can't be negative. You can't end up with the square root of a negative 4. What you going to do with that? So we don't want, now what we could do is find where it's negative and throw it out. But on this, you're going to be throwing out like an infinite number of answers, not just like 6 and negative 6. So it's easier to find what works. So I need this answer to be positive or this answer to be 0. Is everybody with me? So if I subtract 10 from both sides, won't I get 2x is bigger than a negative 10? So when I divide both sides by 2, what do I get? X has to be greater than or equal to a what? That is your domain. So don't tell me your domain can't be, my domain can have negative. No, it's not that x can't be negative, it's that 2x plus 10 can't be negative. But if I put a negative 4 in there, 2 times a negative 4 is a negative 8. And a negative 8 plus 10 is 2. And the square root of 2 is a great number. It's not an integer, but it's a great number. I get an answer back out. So you got to go study and you got to look over those notes. You got to know what you're doing. Now, does this have either one of those trouble spots on the first one? So what's the domain on this first one? All real numbers. And then you had a few word problems that dealt with functions. Okay? So make sure that we're clear about linear equations, slope, and all that with applications, and make sure that you do the functions with applications. All right, how do you know if I list the points out whether it's really a function or not? Like if I started going, okay, you got the point 1, 2, you got the point 3, 4, you got the point 5, 6. Is this a function? How do we know if something's a function if you list the points? Your domain cannot repeat. So is this one a function? Yes. Now, what if this were 5, 4? Yes. What? What did Caroline say cannot repeat? The domain, which are the x's. Are your x's repeating? No, it's a function. Now, if you have 1, 3, now what? Now it's not a function because the domain numbers repeat. So see, I got to study enough so I know I can just say it. Domain, because you said no, it's not a function. I said, what's a function? You said domains don't repeat. Okay, those two things didn't go together. So you can't just memorize what it says. You have to memorize what it says is step 1. But step 2 is now I got to understand what I just said and apply. Okay, we can't just stop with I can mimic like a parrot. Okay, good. I want you to be able to do that. That's step 1, but we got to go past step 1. Okay, so make sure that you understand about domains. Make sure you understand about functions. Make sure you understand about linear equations. Everybody with me so far? Then you've got that finance part of those finance. Now you had basically 3 formulas for finance, and I'm not going to give you the formulas on the test. What's one formula that you should have memorized for finance?
I equals PRT.
All right, you can say I equals PRT. What's that the formula to get you? Simple interest. So what if I asked you, so how much money's in the account? Like if I tell you that you borrow $1,000 at 3% for 2 years, and I say how much is in the account at the end of 2 years? In other words, that's the total amount. Does this formula get you the total amount? It just gets you the what? The interest. How would you get the total amount? You'd have to take that interest and add it back to your what? Your principal. So another formula, instead of memorizing this one, some of you are going to learn this one. What? All right. So it doesn't matter which one you use. This one just gets you interest. This one gets you the end amount. But I can answer the other question with both. If I want to know what the amount was at the end, I would just take my beginning amount, P, and add it to my interest. Well, over here, this doesn't tell you your interest. It tells you your end amount. So if you know your end amount and you know your beginning amount, how would you find your interest? Subtract them. So it doesn't matter which one of these formulas you memorize, but you have to have one of those formulas memorized for simple. Okay? Then you had another formula for compound interest, right? What's that formula? A equals what? P times 1 plus I to the n. So if it's compounded monthly, everything's got to be in terms of months. If it's compounded quarterly, everything's got to be in terms of quarters. Okay? Now, then you had one that dealt with payments. It also says compounded in the problem. But these problems don't say anything about payments. So if it says something about payments, your formula looks a little bit, it's got some similar to that, but not exactly. There's no P, there's a what in it? An R. And I've got 1 minus what? To the what? All over what? So you need to memorize those formulas. And again, if it says compounded quarterly, everything's got to be in terms of quarterly. Okay. So is everybody kind of tracking with what's, now are inverses on your test? No, inverses are not on your test. All right, so it's basically what we covered out of chapter 2. So you need to kind of go back and look over all that. Make sure you can graph. I'm going to ask you to graph some things. If you know the basic shapes, that's going to be helpful. Because if I ask you to graph something like y equals x squared minus 8, what picture should you get if it's y equals x squared minus 8? Parabola. So if you know it's going to be that basic parent parabola drop. You know, but it might be y equals x minus 3 in a parenthesis squared. Isn't that still going to be a parabola? But this time it doesn't drop it. It either moves it left or right. And to me, this one's a little counterintuitive. It's going to move it right. If it's plus in the middle, it's going to move it what? Left. But you make the t-tables. Everybody with me? But it is helpful to know what it's supposed to look like before you make the t-table. What's the absolute value look like? A V. What does cubed look like? That S. Square root, what's square root look like? That's half of a parabola. Is everybody with me? So if you know those basic shapes, that'll help you when you're graphing. All right. So make sure we study.
So
All right,
it's
question, Tucker.
2.2 to 2.6, correct?
Yes.
37.
2.2 to 2.6.
Hey, Director.
Yeah. All right, now, what we're going to do next is we're going to finish up this section on exponentials. So in section 4.2. Now, on the board last time, I had drawn you a picture of what y equals e to the x looks like. So you better be able to graph it. Okay, for test 3. Now, do we understand that e is just a number? What integer is e close to? It's about 2 point what? 7.1. So is it closer to 2 or 3? 3. It's a little closer to 3. It's a little below 3. Now, pi is another irrational number. It's close to 3 too, but it's a little what? Bigger than 3. So those two special irrational numbers in the real world come up a lot. They come up different places, but E comes up a lot in science and business. All right. Now, we made a t-table last time, so I want you to get your calculators out in case you have to do this on your third test. So pull your calculators out. And I want to know this answer. What if x is 1? So you type in your calculator and find me e to the 1. What do you get? You get e, right? What's e about? 2 point what? 7.1. So I'm just going to put 2.7. Is everybody with me? All right. Now, what if it's 0? What if you put e to the 0? Does everybody get 1 when you put e to the 0 in your calculator?
Yeah.
So again, if you don't have an e button, you're doing about 2.7 to the 0. You better get a 1 on your machine. Is everybody getting that? All right. What if you put in a -1? What's e to the -1? About what number? Okay. So again, if you don't have an e button, you do 2.71, but make sure again using that negative key that you're not using the other. So is it about 0.3 or 0.4? About point what? 4. Is everybody with me? Because I'm going to be doing it by hand, so I can't get super accurate. Put a 2 in there. All right. What's e to the 2 about? Okay, I need to do mine, see if I agree. All right, what'd y'all get about 7 point what? 4, okay. All right, what if you had an e cubed? Get about 20. Is everybody with me? Let's do one more. What if you have a negative 2? What's e to the negative 2 about? What did y'all get about point what? 1.4. Now, does everybody understand why that makes sense? I mean, isn't e about 2.71? So that's negative, so I can put 1 over to be 1 over that. So that'd be about 1 over 2.7 squared. Is everybody with me? See how it's tiny? So look what I got. If I graph 0, 1, wouldn't I be right there? All right, now I've got to graph 1, 2.7, so I'm not quite up to 3. Then I got to graph 2, and it's about 2.71. So 1, 2, 3, 4, 5, 6, 7, 8. So it's about right there. All right, now I've got to go negative 1. So here's negative 1. It's not quite up to a half. 0.4, right? All right, when I go out to negative 2, what did y'all tell me that I got when I went out to negative 2? About 0.14, so about 0.1. So it's real small, isn't it? So does everybody understand that this is what your graph looks like when you graph y equals e to the x? Are we good? Now, they're going to ask you some things. They're going to ask you things about domain. They're going to ask you things about range. They're going to ask you things about like x-intercept. They're going to ask you y-intercept. They're going to ask you several questions about that graph. Now, what's domain? Is domain x's or y's? X's. Do you have points with positive x's? Can x be 1? Can x be 2? Could you have e to the 100 if you wanted to? Yeah. Can you have e to the 0? Yeah. Can you have e to the negative numbers? So you understand that your domain is just all real numbers. You can take e to any number you want to and get an answer back out. Now, range, what numbers are range? They're not the x numbers, they're the what?
Y.
What do you notice about all the y's on your points?
They never touch that one.
They never touch this. So what does that mean? X can't, what's y never going to be? It's never going to be 0. Is it ever going to be negative? Do you see that all of your y values are positive over there? So that's what they're going to tell you here, that your range is from 0 to infinity. Now that's just a fancy way of saying start at 0 but don't include 0. Remember we talked about that parenthesis versus that bracket? And it goes forever. You might just say all positive numbers. That'd be okay. But you need to notice that your y values are never negative on that graph. Now, what's an x-intercept? What does that mean? Where the graph crosses the what?
X-axis.
What about this picture?
So
Does it cross the x-axis? No. So what about the x-intercept? I don't have one. None. I don't have an x-intercept on that picture. Now, what is the y-intercept? Where it crosses the y-axis. Do you have a y-intercept on that picture? 0, 1. So you can memorize that or just draw it and look at it. Is everybody with me? You should be able to just get those answers by just looking at the graph. Now, remember when you look left to right, is that graph increasing or decreasing? Is it going up or down? It's increasing. It's going up. They might ask you that. But again, I'm just going to look at the picture and answer the questions. Okay? Now, You've already done some applications of this, but I want to do another application of this. Now, here's one of the applications that you've already done. Now, it doesn't always have to be E. Remember the part on the test where you're doing compound interest? Don't you have a variable, doesn't that turn into a number? That's an application of exponentials. You got a number to a letter up there. So look in your books on page 3, let's see where it is. On page 352. All right. Now we're going to work the first two, then I'm going to work the third one real quick. The first two can be on your test on Friday. The third one can. Okay, it's going to be on test 3. Look what it says on page 352. Example 7 says this. You invest $12,000 at an annual rate of 3%. Find the balance after 5 years when the interest is compounded quarterly, monthly, and then we're going to talk about continuously. That's the new part. Now, is that simple interest or compound interest? What word's in the problem? Compound. Does it say anything about payments? Doesn't say anything about payments, though, does it? So that's how I know it's this formula, not the R formula. Okay? So A, P, I, and N. Now, is A the beginning or the end amount? What does A mean? End amount. What's the P? The principal. So it's the beginning amount. Is everybody with me? So what is that $12,000? Is that the beginning amount or the end amount? We're on page 352. So make sure you bring your books. Okay. So what is that 12,000? The beginning amount or the end amount? The beginning. So it's my P. 12,000. Now what's my interest rate? They told me interest rate was what? 3%. Doesn't say, so it must be per what? Per year. All right. What's my time? 5 years. Now, but what does it say? On the first one, it says compounded what? Quarterly. So everything's got to be in terms of quarters, and mine's in terms of years. So how many times a year is quarterly? 4. So what am I going to do with this 0.03? I'm going to divide it by 4. And when I do, I get 0.0075 per quarter. All right, how am I going to change years to quarters? I'm going to multiply by 4 and get how many quarters? 20 quarters. Now I'm ready to go because everything's in terms of quarters. We okay? So I've got my principal is 12,000. I've got 1 plus. I'm not going to put 0.03. I'm going to put 0.00 what? 75. And my N isn't 5. What's my N? My N is what? 20. They're going to calculate the interest 20 times. Every 3 months for 20 years, they're going to do the interest. Now, what's my order of operations? What do I have to do first? Parentheses. So I've got my 12,000. I've got 1.0075 raised to the 20th. Now what do I do next? Do I multiply or do my power? Which one do I do first? All right, so I take that number and I raise to the 20th power. So I get 1.161184142. I'm not going to round it till the very end. And then I multiply those two numbers times 12,000. And I get about, so as soon as I round it, make sure you change those approximately equal to, did you get $13,934 and about, would it be 20 or 21 cents? 21. That's my end amount. And that can be on your test. Everybody okay? Now they reworked the second one, and instead of it being compounded quarterly, what's it compounded? Monthly. Now I'm not going to take time to work the whole thing. But let's make sure we understand. What would you do with the 0.03? You wouldn't divide by 4. What would you divide by? 12. So if you take that 0.03 and you divide by 12, you're going to get 0.0025. And again, you wouldn't say 5 times 4, you'd say 5 times what? 12 and get what? 60. Now, so do we understand now that would turn into 0.0025 and that would turn into 60. All right, so for quarterly, we had $13,934.21. I'm not gonna take time to rework it monthly because it's worked in your books. They get $13,939.40. So is it a little bit more? Yeah, but not what? Not a lot. Now, the new thing is this. Back on page 351, they talk about compounding continuously. Now, that means second by second by second by second. Is everybody with me? And they give you a new formula, and here's your new formula for continuous compounding. Now, is that one going to be on your test Friday? No. All right, so that's on the bottom of page 351. Top of page 352. Now, the thing about continuous compounding is it sounds cooler than it is. It sounds like you're just going to make $1 billion. Is everybody with me? But the problem is, and they kind of show you the explanation on that page, previous page, with a little bit of calculus, you find out that actually that thing has an asymptote. So you're growing, but once you get to a certain height, you're growing so small, it's really like what? Nothing. So we're going to do this same problem, the C part, where it said continuously. Now, there's some different letters there, and I do that on purpose so you don't get confused. What's P still going to be? It's still going to be your principal, which in this case is going to be the 12,000. Doesn't A still stand for your end amount? E is still like about 2.71. Is everybody with me? Guess what that R stands for? You know what it stands for. What's it stand for?
Rate.
Your rate. And your T is your time. And they just let them both be in years. So they're not going to say, this is compounded continuously. How are you going to change continuously? You see what I'm saying? What do I multiply and divide by? So your R and your T in this formula is in terms of years. So we're going to go work this same problem with it compounded continuously. Now, do we understand that our P is still 12,000? Like Haley said, everybody with me? Now, what's my R? What's my interest rate? It was 3%, and it was per what? Per year. What was my time? It was 5 what? 5 years. Are they in years?
Yes.
So I'm good to go. All right, so you help me out here. What's my P? 12,000. E just stays E. Is everybody with me? What's my power? My power is my interest rate's 0.0 what? 303. And what's my time? 5 years. Everybody okay? Now, don't I have to do powers before I multiply? So I've got to know what that power is. What's 0.03 times 5? Point what?
15.
All right. So what am I going to do first? Am I going to do e to that power or 12,000 times something? What am I going to do first? E to that power. Okay, you got either your E button. If you don't have an E button, then you use 2.71. I'm going to use my E button. So I've got E to the 0.15. I got about 1.161834243. Is that what y'all got?
Mm-hmm.
Now I've got to say that times what? 12,000. I got about $13,942. Now would it be 1 cent or 2 cents? It would be 1 cent. So the only new thing is really that formula. Everybody okay with me? Now look what happened. When you compounded quarterly, you got $13,934 with a little change. When you did it 12 times a year, you got $13,939, right? About how many dollars difference is that? Like $5. Now that is a trip, you know, to get me some Chick-fil-A, but you see what I'm saying? But not the whole meal, just a sandwich. Okay, but I'll take it. Now, look at the difference between this one and this one. Between monthly and every freaking millisecond. How much money is that really difference? About how many dollars? About 3. So it sounds spectacular, but really what? It's not. But it sounds cool. So sometimes it's better to take a different rate at less. Does that make sense? So you got to be real careful. Now, what's due on Friday? We've talked about this, and Caroline brought it up. What's due on Friday?
Video.
All right. In other words, you know, everybody good with that? All right. So your video's got to be posted. Your extras for your podcast has to be posted by Friday. Is everybody with me? Now, your test is Friday. So your homework for Friday is to finish that video if you haven't done it, and don't wait till Thursday night because Wi-Fi could go out. You know how the world works, okay? And study. Now, what's due on Monday? That's Friday, okay? And I will not take it late. Let me stop this real quick.